दिख रहा होगा स्क्रीन शायद।
Hello guys, this is the PCD for starters 59 and Rishabh sir.
हाँ, तो इस क्वेश्चन में हमको एक स्ट्रिंग दी हुई है एस, और हमको बस ये बताना है कि शेफ हैप्पी है या सैड है। शेफ हैप्पी तब होगा जब जो हमको स्ट्रिंग दी हुई है, जैसे ये स्ट्रिंग है, ये वाली AEIOU, इसमें अगर दो से ज्यादा कंटिन्यूअस वॉवल्स हैं, दो से ज्यादा कैरेक्टर्स कंटिन्यूअस वॉवल्स हैं, तो वो हैप्पी होगा, वरना वो सैड होगा। जैसे इसमें तो पांचों ही लगातार वॉवेल्स हैं, तो वो हैप्पी होगा। यहाँ पे कंटिन्यूअस सिर्फ एक ही है वॉवेल, तो वो सैड होगा। यहाँ पे भी दो हैं, लेकिन दो से ज्यादा नहीं है, एग्जैक्टली दो हैं। यहाँ पे लिखा है स्ट्रिक्टली ग्रेटर देन टू, तो मतलब दो से ज्यादा होने चाहिए। यहाँ पे सिर्फ दो हैं, तो इसलिए वो हैप्पी नहीं होगा, सैड ही आ जाएगा। बाकी कहीं पे दो से ज्यादा नहीं है। और यहाँ पे भी ई ई और ए है, मतलब तीन है, तो इसलिए वो हैप्पी हो गया। वही यहाँ पे भी एक्सप्लेन किया हुआ है। तो इसमें हम सिंपल सा वही देख लेंगे, मतलब इनपुट ले लेंगे स्ट्रिंग को, और फिर उसमें बस ये देख लेंगे कि कितने कंटिन्यूअस, मतलब कितने कंटिन्यूअस कैरेक्टर्स वॉवेल्स हैं। तो कोड दिखा देता हूँ। हाँ, तो ये रहा कोड। पहले हम टेस्ट केस ले ले रहे हैं, फिर स्ट्रिंग इनपुट ले लिया, फिर उसके बाद उसका साइज निकाल लिया। फिर ये मैंने टी लिखा है, यहाँ पे कुछ और भी लिख सकते हैं, पता नहीं मेरा एक्सेप्ट कैसे हो गया, मैं खुद सोच रहा था, मतलब मैं टी दो बार यूज किया हूँ, फिर भी एक्सेप्ट हो गया वो किसी तरीके से। मैं चेंज कर देता हूँ। हाँ, तो यहाँ पे मैंने एक एच ऐसी डमी वेरिएबल मान लिया जो काउंट करेगा कितने कंटिन्यूअस वॉवेल्स हैं, और आई आई यही है जो फॉर के अंदर लिखा हुआ है। तो जब तक वो नल नहीं आ रहा है उस स्ट्रिंग में, तब तक हम लोग ये लूप चला रहे हैं। तो एच मतलब जो अपना डमी वेरिएबल है, जो वॉवेल्स का काउंट है, जब वो 2 से बड़ा हो जाएगा तो हम इसको ब्रेक कर देंगे, और ये वही वॉवेल्स हैं, तो हम इसको, वॉवेल्स हैं अगर तो प्लस करते जाएंगे इसको, और नहीं तो इसको 0 पे वापस इनिशियलाइज कर देंगे, ताकि वो वापस, मतलब जैसे यहाँ पे ए है, तो ए के बाद वापस कोई अगर वॉवेल आ गया तो वो वापस 0 से स्टार्ट करे काउंटिंग, तो इसलिए यहाँ पे हम 0 से वापस उसको इनिशियलाइज कर दिए। उसके बाद अगर वो बीच में ब्रेक कर गया तो आई जो है हमारा लेंथ से छोटा होगा। अगर आई हमारा लेंथ से छोटा है तो हैप्पी प्रिंट कर देंगे, मतलब बीच में ही वो ब्रेक कर गया, इस स्टेटमेंट को एग्जीक्यूट कर दिया उसने। और नहीं तो सैड है वो, मतलब एक या दो है या उससे भी कम है वॉवेल्स। तो यही था कोड। कुछ डाउट है?
Perfectly fine. Adi?
हाँ हेलो,
हाँ
एक मिनट शेयर कर देता हूँ screen। सो फर्स्ट वाला क्वेश्चन है सस्पेंस स्ट्रिंग, जिसमें हमें क्या करना है कि पहले दो केसेस हैं, लाइक देयर आर टू पीपल, एलिस एंड बॉब। एलिस को बनाना है स्मॉलेस्ट लेक्सोग्राफिकली स्मॉलेस्ट स्ट्रिंग, और बॉब को बनाना है लेक्सोग्राफिकली लार्जेस्ट स्ट्रिंग। सो बेसिकली हमें जो स्ट्रिंग दिया गया है एस, उसके फर्स्ट से और लास्ट से हमें, मतलब एक फॉर लूप में पहले सारे कैरेक्टर्स को एक एक करके मतलब इनपुट जब लेंगे तो एक एक कैरेक्टर देखना है। फॉर एग्जाम्पल लेट स्ट्रिंग एस इज इक्वल्स टू 1010, फिर टी पहले एम्प्टी होगा, राइट? तो पहले अगर एलिस एलिस का टर्न फर्स्ट होगा तो वो फर्स्ट वन लेगी। तो लाइक See, wants it to be lexicographically smallest, right? So once the first character doesn't matter, you just insert it as it is. And then as Bob takes 0 and he wants it to be lexicographically the largest. So he has to insert it before T. So here the case comes as, sorry, it comes as S of I plus the string that you had taken, right? Then Alice. Alice takes the next second character from the left side. So that is 0. So for 0, she has to take it as the lexicographically smallest. So 0 has to come before the string. So it will be like this. So the case for this will be T. Sorry. Yeah, no.
आदि लाइक वो जो इससे पहले वाला
हाँ,
0 1 के पीछे जाएगा.
Yeah. Sorry. This will be T plus S of I, okay? So since Bob chooses 0 and he has to get it lexicographically largest, so it will be 1 plus 0. And then Alice chooses the second character from the left side. So this has to be lexicographically the smallest. So it has to come before the string. So this will be 0 here. And then Bob takes the second character from the end. So this has to become lexicographically the largest. So it has to come before the whole string. So basically there will be 4 cases. There will be 4 cases, one of Alice, 2 of Alice and 2 of Bob. It depends on whether Alice picks 0 or 1. If she picks 0, if Alice picks 0, it has to come before the string because she has to get it as lexicographically smallest. And for 1, it has to come after the string. And for Bob, it is just the opposite, the vice versa. So basically so for my code, I took the length of this string, then the input for the string, and then okay, this is not needed. Okay, then I just took a new string as an empty string, and then I just did a loop from the first of the string till the middle. So basically I submitted it first and then I came to know of an error. It is that when it is an even numbered string, this whole case is correct for it. But if we look at the possibility for an odd numbered string, the middle character gets blanked out here. It does not take into account. So you have to add a simple case at the end for the middle character in a odd string. So basically this is the whole code. Okay.
Adi, continue with the other two.
Okay.
Next one.
So the second question was the confusing concatenations. Okay. So okay. This, yeah. So this is basically okay. So basically you have two arrays. Okay. Let's take it as S and T. So basically you have numbers x1, x2 till xn. And the second array contains of y1 till yn. So what you have to do is you have to check the leftmost element of both the arrays. For example, here it is x1 and y1. So if x1 is less than y1, you have to, in the new array, it should be x1. And if it is x1 is greater than y1, the first element of the new array should be y1. So basically, you have to choose the smallest out of the two integers, out of the two leftmost integers of both the arrays. So since the output format does not define any like the storage, the number of elements in both the arrays that you have to print, like A and B. Initially, you have been given the resultant array. This is the array. This is the array you have been given, and you have to find S and T. The first case is you have to check it like my first approach was you have to check all the elements if it is less than or greater than. So since it has been said that you have to print -1 when it is not possible, and it will not be possible when all the elements will be in either descending order or the max, that is the maximum element will be the first element. For example, let's take an example, x1 and y1, all the elements of this array, let's say, is smaller than y1. So you have like we can get x1 comma x2 till xn and then y1 to yn. Like the last here it is given, if either A or B becomes empty, append all the remaining elements of the other array to the end of C. So since the size of the arrays S and T is not defined, we can use any like any size for S and T, right? So we have to basically find the largest element in all of the elements of S and T. We have to, while inputting, we can find out the maximum element, and then we can, all the elements present before it can come to the first array, and all the elements present after y1, including y1, will be present in the second array. Okay. So basically, you have to find the max element. But what if the max element comes at the first place? Like at I equals to 0, it is the max element, like x max. So now there is no elements before x max. So you cannot insert elements in the first array, and thus it will be a case where it is where you have to print -1. This. If it is not possible, it will not be possible when you have like the first element will be the maximum of all the elements present in A and B. So if we go to the code now, it is first test cases. I input a number, declare an array of size n, then I assign max like a variable with the smallest integer, and I take a variable as -1. Then I find the index of the maximum element, right? So first the now just take a look at the output element. First you have to print the number of elements in A. So as I said, the number of elements present before y1, like before the maximum element should be present, should be printed first. So here comes p, and then we print all the elements till the max element, so I less than p, and then we print the number of elements in the second array, which is n minus p, and then we print all the elements which are present, including the maximum element which are present. So that will be element b, and that will be element 1. And this is the case where the first element is the maximum element. So if the first element is the maximum element, there will be no array, there will be no elements in the first array, and thus it will be an invalid case. Now, if we go to the third question, this is the maximum subarray. So, element 5. Okay. Okay. So first we are given two arrays, A and B, okay, of A and B. And it is given that we can choose either the first element of B, like let's take it as B1, and the last element of B or Bn. Okay. Sorry, Bm, let's take it as Bm. So here there are already n elements, and then we have to take either the first element of B or the last element of B and insert it insert it either in the first or the last element, either in the first of A or in the first last of B A. So basically we have to and we have to find the maximum subarray, that is the sum of the maximum number of elements that are given. So since we can see in the constants that the elements can be of negative value too. So that makes our work easier. We can just find the maximum subarray of this. First, you have to find the maximum subarray that is already present in A. So basically, we have to keep on adding elements from the first and from the front end and from also from the rear end. Like we have to keep on adding x1, like okay, a1 and a2 till n, and we have to keep on checking whether the sum of the subarray exists or not. Like we have to take max of subarray and the resulting sum. So let's take it as S1. So for example, if we take A1 first, and first we input A1, and then we input A2. So we have to check first A1 comma A1 plus A2. If A1 plus A2 is bigger, that replaces S. That replaces the element. For example, let's take it as P, and let's make this as P. Okay. So this is P. P will be initialized as 0. We have to find the maximum of the sum of the subarrays. So we have to do it twice, once from the front end and once from the rear end. And after doing that, it's just simple. After that, we have to check all the elements of B, like from 1 to n, if it is greater than 0. Since it is not given, like there is no constant on adding like a fixed amount of integers on the front end or the back end, we can keep on adding from the left end or the right end. For example, let's check. Let us assume P, we have got something as P. Now all the elements that we have in B which are greater than 0, like all those are positive and will add something to the sum, we can add it at the same end as P. So ultimately this is P, and this is all the elements from B. So this will all be added. So ultimately it will be P plus P. And if any element is added that is less than 0, like it is negative, we can add it in the other end and it will not be added in the resulting subarray. So if we go now to the code, we can see first we have taken number of test cases, input the integer, declared an array, and then as the input string. Yeah, then we have seen here, this is S plus SI. This is actually the one from the front end. Okay, I have done it in a single loop. So this is from the back end and this is from the front end. I like it keeps on adding, and then I here it is the max, which is the condition, like to check if the current sum is greater than the previous sum, or the previous sum is still the greatest. So this finds the greatest subarray in the whole of the array. So basically, after doing that, we can just check it how the number of elements in the second array which are greater than 0, and we can add it to the resulting sum, the sum that we got from here, and we can add it, and all the negative elements will be added, will just be discarded, and thus we can print the last sum here. And just keep in mind to use long int, which I made a mistake. Thank you.
Okay, thank you, Aditya. Mayank?
The problem alternate suffering. We were given a binary string S, and we were given a scenario where we had to do this operation simultaneously and independent for all ones. The operations was change the bit from 1 to 0, and if there is a 0 to the left side of 1, it will be changed to 1, or if there is 0 to the right side of 1, it will be changed to 1. For example, if the string is 0, 1, 0, then this 1 will be changed to 0, and since this 0 was to the right of a 1, this will be changed to 1, and this 0 was to the left of 1, this will be changed to 1, as we can see here. Now our task was to calculate what will the string look like after exactly k operations. So there was some observation in this problem. Like suppose I take the last test case, this one. I have written down a couple of moves. Like this is the first move, which like this will be the string after the first move, and this will be the string after the next couple of moves. Now what I observed from here is, suppose this number is 1 after the first move, then this position will keep on alternating. Like here it is 1, then it will become 0, 1, 0, 1, and so on. This position is always alternate. And suppose there is a 1 in this position, then this position will always alternate between 0 and 1. And same for this one also. So like now consider this position, it is 0. So when will it turn to 1 for the first time? I saw that after the second operation it turned to 1, and after that it will also keep alternating. So this was the main logic. For each index, I will calculate when it will become 1 for the first time, and after that it is easy to see that we have to check the parity and then we will get the answer. Like suppose I have this 0, I have to check when it will become 1 for the first time. So it will become 1 after the first time. After 2 operations, like as we can see here. So basically, for any index, if I see the position of the one to the left and the position of the one to the right, so the minimum distance will be minimum of this and minimum of this. So for each 0, we have to calculate when it will become 1 for the first time, and after that it will keep on alternating, and then we can check for the parity. Any doubt in this one? You can ask freely.
Mind, please show the implementation. How you implemented this?
Implementation is first I simulated the first move. This is the first move. And then suppose my k was 1, then I printed the string as it is. I decrease k by 1 because I have simulated the first move. And after that, I created a vector where I stored all the position of 1s. After that, in the string, I checked, like suppose for this 0, I have to find when will it become 1 for the first time. And the answer will be the minimum between this distance and this distance. So how will I calculate this? Like suppose my position is 0, I will check for the 1 just next to my current index, and I have used the inbuilt lower bound function here. And same for the previous index, I just calculated the distance of the right one and the left one from particular 0, and then stored it in my map. And after that, I know for each index when it will become 1 for the first time. And then suppose my current index is 1, so I know that it will keep on alternating between 1 0 1 0 1. So I have to check, like when after k seconds it will be 0 or 1. For that, I just wrote some couple of cases, and I found out that if this value k minus, then the distance between the distance when it will become 1 for the first time plus 1 is odd, then I have to print 1, otherwise it is 0. Like this formula came after I tried a couple of examples. That's how we got it up. This was unnecessary, but this was good. That's how I implemented it. Like
Thank you, Aditya and Mayank, for the post-contest discussion today. Good night, everyone.